In equilibrium, the excess diamond vector must be equal to 0. You remember, the alternative definition of equilibrium is the null vector belongs to Z of P star. This definition of equilibrium is absolutely equivalent to this. Obviously, if you multiply this null vector by 0, you obtain clearly 0. The total value of excess demand vector when we are in equilibrium is equal to 0. In other terms, in equilibrium, strict Varro's law holds. It is not necessary that strict Varro's law hold in for every price system, but surely it holds in equilibrium. Usually, in order to prove the existence of equilibrium, two assumptions are made. First, while strict Varro's law and do you remember, strict Varro's law is a consequence of local non-saturation of the preferences of every subject. Second, free disposal for at least one firm. In reality, if you omit or both strict Varro's law or free disposal, generally speaking, it's not possible to prove the existence of equilibrium. It is necessary to use some alternative assumption. If these two assumptions hold, it is possible to demonstrate, to prove the existence of equilibrium in an alternative way. A vector rewrite, let us rewrite it. A vector like this, you remember, is a general economic equilibrium if it verifies these three conditions. However, if we assume strict Varro's law, so local non-saturation for every consumer, and free disposal for at least one firm, you can prove that an equilibrium exists, put attention, if there exists a vector like this, which verifies B, C, instead of A, this condition A prime, sum of x star h lesser or equal to sum of omega h plus sum y star f. I repeat, if these properties hold, in order to prove the existence of equilibrium, it is sufficient to prove the existence of a large vector like this, which verifies A prime, B, and C. If you succeed in finding this vector, you can prove that there is another vector which verifies A, B, and C, and vice versa. So, it is equivalent to prove that these three conditions holds, or to prove that A prime, B, and C hold. But this is not generally true. It's true only if these two assumptions are verified. The proof is not very difficult. It's a so-called free disposal equilibrium of before. Well, one of the implications is absolutely obvious, because if there exists a large vector like this, which verifies A, B, and C, then there exists also a large vector, the same vector, which verifies A prime, B, and C. Because if this vector verifies A as an equality, it verifies also A prime as a weak inequality. So one over implication is entirely obvious. But let us prove the converse implication. Suppose that we found a large vector like this, which verifies A prime, B, and C. We must prove the existence of another large vector like this, which verifies A, B, and C. Is it clear? This is the more difficult part of the theorem, however, it's not very difficult. Well, we know that there exists a large vector which verifies this inequality. Compute the excess of demand, Z star, which as usual is nothing but the sum of X star H minus the sum of omega H minus the sum of Y star F. By assumption, this vector, this excess demand vector, has all negative components. Is it clear? Moreover, by strict Varro's law, this vector has a null value. I repeat, Z star is a non-negative vector by A prime. Is nothing but the difference between the left-hand member and the right-hand member. And since it is a vector, or demand, excess of demand vector, by strict Varro's law, it has a null value. Moreover, there is a third, let us suppose the first third, for the sake of simplicity, which has a free disposal technology. It activates the process Y star F. But put attention, since vector Z star has all negative or non-positive components, by free disposal, if you add to this process Y star F the non-positive vector Z star, you obtain another vector YF, which is an element of a production set. Why? Because this vector YF, note, has all the components less or equal than Y star F, since Z star has all non-positive components. But what is the value of this alternative process? Let us compute it by multiplying by the price system. And you obtain this result. A simple algebraic manipulation. I multiplied both sides of this equality by P star. I obtained this equality. But P star times Z star is 0. So this is exactly equal to P star times Y star F. What is the meaning of this result? Simple. YF is another optimal process because its profit is exactly equal to the profit of Y star F, which maximizes the profit in the production set. So you conclude that this alternative process YF is an element of SF of P star. Final step. If you substitute here to Y star F YF, clearly you obtain a strict equality. Because the F firm is destroying the excess of demand. Sorry, the excess of negative excess of demand, in other terms, the excess of supply of some goods, since Z star is a non-positive vector. If you substitute in this large vector to Y star F, you substitute YF, clearly, instead of an inequality, you obtain a strict equality. And you prove the existence of another large vector which verifies A. The conclusion is, in order to prove the existence of equilibrium in the general sense, the proper sense, it is sufficient to prove the existence of a large vector which verifies A prime, B and C. Well, right, and then I shall repeat all the demonstration. This is the definition of equilibrium. But now we suppose that Warner's law holds in a strict form and that there is at least one firm which has free disposal technology. Under these conditions, to prove the existence of equilibrium, to prove the existence of a large vector which verifies A, B, and C, is entirely equivalent to prove the existence of a large vector which verifies A prime, B, and C. A free disposal equilibrium in the case of production. In order to prove one implication of the theorem is trivial. Let us suppose that there is a large vector which verifies A prime, B, and C. We must prove the existence of another large vector which verifies A, B, and C. Let us consider the excess demand vector determined by this large vector, Z star, which is, as usual, is the difference between this sum and this sum. Clearly, by condition A prime, this vector is a non-positive vector. Moreover, since it is an excess demand vector, by strict Warner's law, its value is equal to 0. Is it clear? Now consider the firm, the F firm, which has the free disposal technology. And consider the vector YF, which is equal to the optimal vector Y star F plus this vector Z star. But Z star has all non-positive components. So by free disposal, this vector YF is another element of large YF. Is another technical process for the firm F. Its value, by multiplying by P star YF, you obtain this result. But note that the inner product P star times Z star is 0. So the value YF is exactly equal to the value of Y star F. This means that YF is another element of supply correspondence, because clearly Y star F guaranteed the maximum profit, and therefore also YF has the same property. So, if you, in this large vector, to YF star substitute YF, you obtain another large vector which verifies B and C and also A, because the difference between these two hands of inequality are simply destroyed by the firm which has the free disposal technology. Is it clear? Note, if the wireless law is not verified in a strict form, or free disposal does not prevail, and not necessarily so, this equivalence does not hold generally. But under these assumptions, it is always verified. To prove the existence of equilibrium by A prime, B and C, it is simpler than to prove the existence of equilibrium by means of A, B and C, as we shall see in the following lessons. Well, let us have another short break.